and welcome to Chemical Science Made Simple. I am Wisdom Benjamin. In today's lesson, we shall be looking at the naming of the compounds of alkenes with double bond, of course. Make sure you subscribe to our channel if you're yet to do so. Alkenes are organic compounds with double bonds between the carbon-carbon atoms in a carbon chain. And because of this, they are said to be unsaturated compounds. They have the general formula of CnH2n and a functional group of C double bond to C. The naming of alkenes follows the same procedure of naming alkane, only that the ending of alkane is replaced with "-ine" for alkane. For example, we have this compound. This compound is an alkane. Now we have this as alkene. Alkane, the N in alkane is replaced with "-ine" in alkene for the alkene that has the same number of carbon with the alkane. And this is called ethane. Why this is called ethane? So N has now been replaced with "-ine". More examples to further illustrate this. We can have a compound with 5 carbon atoms. Now we fill in our hydrogens. Now let's have a double bond here. Remember, in our previous classes we talked about every carbon being tetravalently bonded. So if we have a double bond here, then only one bond can enter here carrying our hydrogens. Then we'll have hydrogens here, hydrogens here, hydrogens here, and hydrogens. Now this compound is an alkane, a 5-carbon alkane. Now some differences, of course, are observed in the naming of alkane compared to alkane, and one of such is that the alkene, the double bond in the alkene, is given the lowest possible number. We prioritize the position of the double bond. Just the same way we indicate the positions of the substituents when we have them in compounds, we must indicate the positions of the double bonds. So identifying where to count from is very important, and that can only be the side of the chain that is closest to the double bond. Now for the compound we have here on the board, if we count from the left, we have 1, 2, 3, 4, 5. But from our right, we have 1, 2, 3, 4, 5. So counting from right to left, the carbon with double bond appears at carbon 2. The double bond appears at carbon 2, while going from left to right, it appears at carbon 3. So right becomes the direction to count from, because that will give the double bond the lowest possible number. So this compound, as a 5-carbon alkane, 5 carbon simply means pent. We've discussed that in our previous classes. 5 carbons pent. So this compound will be pent. Now the position of the double bond is 2, pent 2, and is an alkene. Remember, the N will now be replaced with "-ine" of alkene. Pent 2-ine. Now this is the name of this compound, pent 2-ine. We can also have substituents attached to the carbon chain. For example, if these are compound 6-carbon alkane and we have a double bond here, and then we have some substituents attached here, Now looking at this compound, we can count from left to right. 1, 2, 3, 4, 5, 6, 7. Now there are 7 carbons in the carbon chain. The longest possible number is carbon, so it's 7 rather. 7 carbons in a chain gives us hept. Let's not forget that. Hept. Then this is part of the chain. This is from the substituent. 1, 2, 3. 1, 2, 3 gives us 3 for the number of the carbon with the double bond. From left, 1, 2, 3, 4. So counting from right, we have 3. From left, we have 4. Despite the positions of this or the presence of this substituent, we must make sure that the double bond in our alkene is given the lowest possible number. This is very important. Despite the fact that we have substituents appearing at carbon 1 from the left, we won't count from the left because this is an alkene. We will count from the right, given the double bond the lowest possible number. This compound therefore will be counted in this manner: 1, 2, 3, 4, 5, 6, 7. Then, as well, just like alkane, we will put our substituents and also put their positions. Now, bromine is 2 bromines are in carbon 7 and a chlorine at carbon 6. Now, bromo comes before chloro. So, at carbon 7, there are 2 bromine. So, we can have 7 dibromo, 6 chloro, then 7 carbon generally we have hept, 6 chloro, hept. At carbon 3 appears the double bond, so hept 3 in. 7 dibromo, 6 chloro, hept 3 in. 1, 2, 3, 4, 5, 6, 7. Now let's take a look at another example here where we can have 2 or more double bonds in one particular carbon chain. And when we have that, just like when we have 2 bromine here, we say dibromo. When we have 2 double bonds, it will be diene. We can also have triene. Now let's take a look at this example. 1, 2, 3, 4, 5. Let's have one here. Let's have one here. Then we'll have hydrogens here. Then let's have a bromine here. Then we'll have this here. And then looking at this compound very well, all the carbons are tetravalently bonded. That's very good. So we have double bond at carbon 1 counting from left, at carbon 1 counting from right, and at carbon 3 either left or right we have the bromine. So we can count from any side, left or right. Now the most important thing here is that this particular chain contains 2 double bonds. So we have 1, 2, 3, 4, 5. This is a 5 carbon compound, so it's going to be pent. And at carbon 3 there is a bromine, so this is 3 bromo pent at carbon 1 and at carbon 4. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. 1 and 4 contains the double bond, so this is pent 1, 4 diene. 3 bromo pent 1, 4 diene. 1, 4 showing us the positions of the double bond. More examples can also be used to illustrate the nomenclature of alkenes. Don't forget to subscribe to our channels so as to get more of our